ion and ion and atom. So here, if you compare which has greater atomic size, here atom, comparing with its positive ion. So when the positive ion formed, positive ion has, right? Positive ion has less size, right? Because nuclear charge is greater comparing with electron cloud. Nuclear charge is greater comparing with electron cloud charge. Okay. If it is negative ion is formed, right? Negative ion, right, has greater atomic size. Why it is greater? Nuclear charge is less, right? Nuclear charge is less comparing with electron charge. Are you clear about this? Have you got clarity or any confusion left here? Just you need to observe these by taking the number of shells around the atom and around the ion, right? With number of electrons into the valence shell. Are you clear about this or not? Right? So this is, you need to understand clearly. If you understood this one very well, very easy to answer that ion even in your textbook. In your textbook already that comparison is asked by giving chlorine, right? Chlorine, sorry, different atoms are given, iron, etc. Comparing their own atoms, right? So Fe, Fe2 plus, F and F minus, like that. So comparing the atom size with ion. So that you need to complete that. So have an idea like this, then compare it. Right? Then we are going to discuss about another characteristic property here, that is simply about ionization energy or ionization potential. Ionization. What is ionization? Making the atom ice charged body. So how do you make it? By removing the electron or by adding the electron? So you have difference. So removing the electron and adding the electron. Removing the electron, make it positive charge. Adding the electron, making negative charge. So simply that we are trying for. Ionization energy or ionization potential is defined as simply what the energy is required to remove the electron from its valence shell. For example, in the last discussion, I said I am removing the electron from the sodium atom. So, to remove that electron, do you need any energy? For example, if you want uh, something to take it from others, right? If he is giving you, it is easy to take it. Suppose if he hold, right? You need to apply force on that to take it from his hand, right? You need to apply force because he is holding that. Likewise, here electrons are holding in their shells due to the attraction force. Do you agree? How they are fixed in the atom because of nuclear charge. Do you agree? Electrons are stably available within the nucleus due to attraction power, right? So simply that attraction power is there on each and every electron. So you are trying to remove the electron. So that attraction force will not accept that one. So here you need to increase your force to remove the electron, right? How much? Increasing the force more than the nuclear attraction power on the valence shell electron, right? So that's why you required energy to remove the electron from the outermost shell of a neutral gaseous atom. So that is called as ionization energy. So this ionization energy is simply measured in kilojoule per mole. This ionization energy is measured in kilojoule per mole. So here you are trying to remove electron from the valence shell. Suppose if you are trying to remove electron, first electron, right? So what amount of energy is required to remove the first electron from the valence shell? That energy is called as first ionization energy, right? So that we will discuss. So the tendency of ionization energy in the group. Tendency of ionization energy in the group. So here that is increases or decreases? Decreases, right? So why that ionization energy decreases? Atomic size is increasing. What happens atomic size increases? So you know, in the Bohr atomic model, right, it is tested when you move from the nucleus, away from the nucleus, right? What happens? Size of the atom increases and energy of the outermost shell increases. So E1 is less than E2, E2 is less than E3, as we discussed here. So greater energy and nuclear attraction power on the valence shell decreases. Right? Suppose imagine magnet. Imagine magnet. Right? Suppose if there is something magnetic material close to the magnet, so greater attraction power. Suppose that material, same thing, moved away from this, so less attraction power. So as you thought there, or as you understood there, same you can imagine here also. Attraction power of the nucleus decreases depending on the distance. As the distance increasing from the nucleus, nuclear attraction power decreases. As the attraction power decreases, it is easy to remove the electron from the valence shell. So when the atomic size increases, automatically ionization energy decreases. Less attraction power, less energy required to remove the electron from the valence shell. Is it clear? Raise your hand if there is any doubt, or go to quick reaction if it is clear. Why the ionization energy decreases? With increase in atomic size. So where the atomic size increases within the group. So atomic size increases, ionization energy decreases. So here, due to the decrease in the nuclear attraction power, that also you need to mention in your answer. Right? Then the tendency of ionization energy within the period. So within the period where the electron enters within the same period into the same shell or into the different shell. Answer me. Anyone? Where that differentiating electron enters within the same period into the same shell or into the different shell.
Sir, into the same shell.
Into the same shell, right? For example, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, and neon we observed. So what is outermost shell for them? L shell. K is inner shell, L is outer shell. Suppose if you go to another potassium, one more shell will be added, M shell. K and L are inner shells, M is outermost shell. So here, simply electrons are entering into the same shell. So same distance is available. Same distance increased by nuclear charge. For example, here I am showing you potassium, right? Suppose around the potassium, how many shells are there? First shell, K shell, around the potassium, K shell. Next shell is L shell. Next shell is M shell. Next shell is N shell. So K, L, M, N. So for the potassium, 1 electron. If I go to the next one is instead of potassium, what will take calcium? So one more electron will be added into the same shell. So distance not increased. But what happened? Potassium has 19 ice proton charge, calcium has 20 ice proton charge. So nuclear charge is greater for calcium. So nuclear charge increased on the same valence shell. So automatically that electron cloud comes down. So atomic size of potassium is less comparing with the atomic size of calcium. Do you agree? Is it clear? Especially teacher, because you are 10th class student. Remaining all three members are 9th only. Is it clear? So very good. So now here we are understood about the difference in the atomic sizes when we move from left to right. Suppose if I go to the next element, 21st element, where the electron will enter in scandium. Teacher, answer me. Scandium now. 21st electron enters into M shell or N shell. I am giving you hint. N shell or M shell, where it will be entered. Fast. Wasting time. Maybe you are writing the electronic configuration. Are you?
Yes, sir. Yes, sir.
No need. Here, 4s to 3d1. 4s to 3d1. So, it is entering into, see here, third shell n equal to 3. So, the differentiate electron enters into inner shell. So, for the scandium atomic size is increased or decreased? For the scandium, atomic size is increased or decreased?
So remains same.
No. How it remains same? Wrong. You are mistaken. You are forgetting that logic. Distance not increased. Electron cloud not increased in the valence shell because the electron entered into the M shell, inner shell, and on the valence shell N, suppose. Last shell I am considering N shell. On the N shell, electron cloud is 2 only, but proton count became 21. Nuclear charge is increased. When the nuclear charge increases on the valence shell, what happens? That two electrons again come closer. Greater attraction power. Right? So now, atomic size of scandium is comparatively less than calcium. Less than calcium. So, tendency of ionization energy in periods that nuclear attraction power is increasing on the valence shell, outermost shell. Automatically, what happens? Is the nuclear attraction power increasing? Atomic size is decreasing. Atomic size decreasing. Ionization energy increases. Opposite. Because greater attraction force. Simple. So compare the groups and periods here. Are you clear about this? What about remaining students? Tejaswini, Surajita, Medasri? Are you clear? So for anything from this onwards, you are depending on the nuclear charge and atomic size. That's why I said atomic size is very, very important. It will help you in understanding the nuclear charge. Right? Atomic size from the nucleus to the valence shell distance. Nuclear charge is what? Simply based on the atomic number. Right? So that you need to keep it in mind. So tendency of ionization energy in the periods left to right, it is increasing. Ionization energy increasing due to attraction power increased, then size of the atom is decreased. Right? Keep it in mind. Simple. No need to keep it in your mind. while you are solving these type of answers, just go for this orbitals around the nucleus. Orbits. Nucleus, number of orbits. This will help you easy to understand when the differentiating electron enters into the inner shell or into the outermost shell. Then easy. If you blindly thinking, no use. Definitely you will get confusion, right? This is logical method. The next here, we are learning about ionization energy or ionization potential measured in units. What units? Kilojoule per mole. So that ionization energy types there. First ionization energy, second ionization energy. What is first ionization energy? If you are trying to remove the first electron from the valence shell, that first energy is called as first ionization energy. So what amount of energy you are using to remove the electron from the valence shell, first electron, that energy is called first ionization energy, right? So this energy is represented by IE1, right? For example, if I am using something X element, from the X element, you are removing. What happens if you remove it? Becomes positively charged, then it lost one electron. So to make this unipositive ion, what amount of energy you use it to remove the electron, right? Then only it becomes positive. So that energy is called here first ionization energy. Then you are trying to remove second electron. So from where you are second electron, I am trying to remove unit positive ion. Then it becomes dipositive ion. So again, it loses one more electron. So to remove the second electron, what amount of energy is needed by you? That is second ionization energy. Tell me, first ionization energy is greater or second ionization energy is greater? Anybody answer? And why? First ionization energy is greater or second ionization energy is greater? No one answering me. Maybe you are doubtful. What is second ionization energy? To remove the electron, you required energy. That is from unipositive ion. That energy required to you to remove the electron is called second ionization energy. Right? So now I will give you clarification using the nucleus and shells. Right? So here look at, I'm taking the nucleus with it's a black color, right? Certain element, that is element also I am considering here. Suppose it is maybe lithium, right? What is atomic number of lithium? Atomic number of lithium. Answer
3.
3, right? So how many shells you required? How many shells you required? 2 enough? 2 enough? Yes, 2 enough to remove the electron, right? To remove the electron, to distribute the electron, you require just 2. So electron count I am showing you with the plasma, right? So first I am trying to remove one electron here. So what amount of energy is required? That is called IE1. So no electron, only you have lithium in the nucleus. One shell is available around it. Then 2 electrons are there. Then this atom became now unipositive ion. Are you clear now? How I got unipositive ion? Just go to quick reaction if it is clear. By removing the electron from the valence shell, it is became unipositive ion. Then compare number of electrons present in the Li plus and number of protons present in the Li plus. Electron counts 2, proton counts 3. And look at, is there an electron in the second shell? No electron. Yes. So distance you are measuring from lithium to outermost shell or this shell, K shell. You are measuring up to K shell only because there is no electron. No consideration of this L shell. So we are considering the distance from here to here only. Then atomic size is increased or decreased? Answer me. Fast. Atomic size? Increased. Atomic size is increased. Right? So when the atomic size atomic size is decreased and the nuclear charge increased, attraction force on the valence shell increases. Right? So when the attraction force is increased, now I am trying to remove this electron. I may require more energy or less energy comparing first ionization. I require more amount of energy due to greater nuclear attraction power. That's why second ionization energy is always greater than first ionization energy. Second ionization energy is greater than first ionization energy. Or suppose if you go for removing third electron, third ionization energy is greater than second ionization energy. This you need to keep in mind. So this is about ionization energy. So next here affecting factors also there on ionization energy. What's that? Just now only I said nuclear charge, atomic size. Who are affecting the ionization energy or not? If atomic size is decreasing, ionization energy increasing, nuclear attraction power increasing, ionization energy also increasing. So likewise, we have 5 factors. What they are here, namely nuclear charge, atomic size or atomic radius, then screening effect or shielding effect. Right? So screening effect or shielding effect I will discuss with you. This is nothing but atomic size only because number of shells added. Then penetration power of the orbital. So penetration power we discussed based on the opposite. Right? So because N plus L value is less, that's penetration power is greater. Right? So penetration means the electron passing or entering through into. So that is called penetration power. The next stable electronic configuration. So if it has stable electronic configuration, they are not ready to lose their electron. They are not ready to accept the electron. Then lastly, atomic size. So here, nuclear charge, screening effect or shielding effect, penetration power, stable electronic configuration, and atomic radius. These are the affecting factors. So what is nuclear charge? So nuclear charge is nothing, number of protons present within the nucleus. So that nuclear charge increases with the atomic number. Right? Atomic number increases, automatically nuclear charge increases. Nuclear charge increases, automatically ionization increases. Right? So nuclear charge is nothing, proton charge, proton number, atomic number. So nuclear charge increases, ionization energy increases. What is screening effect or shielding effect? So number of electrons present in the atom will be increase in its shells. So as the atomic number increases, so distribute that electrons into the orbitals, you require more number of shells. K shell, L shell, M shell, and so on. So number of shells increases, right? Then automatically that attraction power of the nucleus on the valence shell decreases. Right? So they are affecting. So that is called screening effect or shielding effect. Decrease of nuclear attraction power due to increase in the cell's count. That is called screening effect or shielding effect. So as the screening effect increases, size increases. Simple. Number of cells added. That shielding effect. More screening effect, less the ionization energy. More shielding effect or more screening effect, less the ionization energy. Next, penetration power. So penetration power is greater. Penetration power is greater than ionization energy also greater. To remove the electron from 2p comparing with 2s, 2p is greater or 2s is greater. Penetration is greater for 2s comparing with 2p. So to remove the electron from 2s, you require more energy comparing with 2p. So that penetration power, less ionization energy due to less penetration power, greater penetration power, more or greater ionization energy. Right? Right? So these are the three factors. The next here example is there. Sorry, that example is 2s and 2p. In these two, 2s require more ionization because of greater penetration. We already learned right? So 2s highs filled first comparing with 2p. So 2s filled first, penetration power is more for 2s. That is the reason to say greater ionization energy is required to remove the electron from 2s. Next one is here stable electronic configuration. So what is stable electronic configuration means? If any atom left their shell with 8 electrons, stable electronic configuration, or orbitals left with half filled or completely filled, then it is called as stable electronic configuration. So atom or orbital, simply orbital. Suppose p orbital, d orbital, p orbital magnetic 6. If it is completely filled, 6 electrons stable. 4 half filled, 3 filled, stable. So with the stable electronic configuration, ionization energy also changes. So here stable electronic configuration is there, you require more ionization energy because of its stability. Right? Suppose here comparing the ionization energy of nitrogen with ionization energy of oxygen. So which is greater in ionization energy? Nitrogen or oxygen? Comparing here. So nitrogen, electron distribution into orbital. So 1s2, 2s2, 2p, 3. So here in 2p level, 3 electrons are filled. Then go for oxygen. 8 is the atomic number, 1s2, 2s2, 2p, 4. So now look at the distribution of electrons into 2p. So this is, sorry. This is. So now look at 3 available, 4 available. It is said to be half filled. It is more than half. Right? So this is the reason to say that stable electronic configuration also affecting the ionization energy. So ionization energy required to remove the electron from nitrogen is greater. Nitrogen is greater comparing with oxygen. Are you clear about this one? Are you clear? Yes. Right. Now we are moving for another property here, that is atomic radius. So atomic radius increases within the group and decreases within the periods. So within the group, within the periods, you are able to compare the atomic size based on the entry of electron into the same shell or into the different shell. Into the different shell, atomic size increases. Into the same shell, atomic size decreases. So when the atomic size decreases, nuclear attraction power increases, then automatically ionization energy also increases. So ionization energy decreases with increase in atomic size. ionization energy increases with the decrease in atomic size, opposite, right? So more the atomic radius, less the ionization energy. This is about the atomic radius. So it is, if we use the term here, I forgot to mention that ionization energy is given with the kilojoule per mole, right? So here we are using electron volt per atom also. We use one time potential. If you use ionization potential, use the units electron volt per atom. Ionization potential units electron volt per atom. Ionization energy units kilojoule per mole, right? So it's taking more time. So next property, electron affinity, I'll discuss with you in the next class. If I take a class in the evening, are you ready to join? Just give me your quick reaction. Are you ready to join? Okay, I'll